So we are continuing our discussion about identities by going to another group. By now we have talked about two groups of identities: Pythagorean identities. Let's just quickly review what that was all about. So you take a triangle. Here's your angle. Pick one of the sides to be 1. We started with this. According to that, label the other sides. So if you remember your unit circle, this was sine theta and cosine theta. Double check with the definitions. Then write the Pythagorean identity, which says sum of squares of the a is the square of the third one. So we had cosine square of theta plus sine square of theta is equal to 1 squared, which is 1. Then we had the other two versions, which was if this is theta and this is 1, this becomes tangent, because ratio of opposite to adjacent has to be tangent. And then the hypotenuse turned out to be what? Secant theta. So we had 1 squared plus tan squared is the square of hypotenuse, which is secant squared. Then we had the third version. This was angle theta, this was 1. This made it cotangent, that made it cosecant. So in this one, sum of square of these two guys, cotangent square of theta plus 1 squared is equal to square of hypotenuse. So these were the Pythagorean identities. Then we had reciprocal identities. So reciprocal, we really had seen them at the beginning of the semester, but here we are refreshing our memory that, for example, sine of theta is a reciprocal of cosecant of theta. Cosine of theta is a reciprocal of secant of theta, or tangent of theta is a reciprocal of cotangent of theta. We said any of these things can be written so many different ways. You have to be good in algebra to see those things quickly instead of memorizing each. Next in the list of simple identities is the negative angle identities. Let me quickly list them and then we go after a demonstration. Why is that so? The idea is that if you go in the negative direction and you are dealing with the strict functions of those negative angles, what do they have with their corresponding positive ones? For sine, let me see if anybody remembers. What was, if I want to deal with this minus, it turns out sine of negative of an angle is minus the sine of an angle. We saw this thing before, and in the section on symmetries and graphs, we said this is indication that sine is odd function. Let me list as a refreshment. Sine is a odd function, or graph of sine is symmetric with respect to, remember, with respect to the origin. When you go back in your notes, you'll see that. As I mentioned, I'm going to come back quickly and explain where does that come from again, but let's list them and then we come back. With respect to cosine, we said if you change an angle to its negative, cosine doesn't make any difference. Like if you measure cosine of 20 and cosine of minus 20, you see that they are the same thing. As opposed to what? As opposed to here, if you had to calculate the sine of minus 20 and sine of 20, you will see that they're off by sign. With respect to cosine, not so. For that reason, we said cosine is what kind of function? Even function. So that also meant that graph of it has a special look. It's symmetric with respect to what? Y-axis. Finally, tangent of negative of an angle, like the sine. If you calculate tangent of minus 20 degrees and tangent of 20 degrees, you see that their signs are different. And that's because of this identity. That gets the same labeling as it did with respect to sine. So tangent is an odd function, and y is equal to tangent of x, then is symmetric with respect to what? Origin. Now, if you are quick with respect to your reciprocal identities, you say that these negative angle identities extend to them as well. So you really don't need to memorize it, but if you wish, let me just list them quickly. What do you think happens to cosecant of negative theta? Negative cosecant of theta. Secant of negative theta is equal to just secant theta, because it just follows that. Cotangent of negative theta is negative cotangent of theta. Let's quickly say, well, what? Let's refresh our memory on that. Many ways of doing this. Our best way is the unit circle or just the original definition. Let's go back to, here is our unit circle. We said on the unit circle we have sine axis and the cosine axis. You have your angle. How did we measure sine? So you want sine, go straight or come straight down. This is sine of theta. Now, good thing about the unit circle is that it can show you negative angle easily. When you say negative, if this is positive, means you're going in the opposite direction, you go here. This is negative theta. So that is going to be sine of negative of theta. Well, what do these two have to do with each other? Magnitudes are the same. This is above, this is below. It simply means sine of negative of theta, the one below, is same as the above, except that the flavor is different. So I said instead of word sine, I have a hard time dealing with this. How do you distinguish between these two words? So instead of sine, sometimes I say flavor. Or I have to say plus or minus of an expression. So the flavor of these two are different. If that's positive, this is negative. That's what this identity is talking about. How about cosine? For cosine, well, let me redraw this thing because the picture is going to get crowded. So if I have an angle, say positive angle theta, and then I have a negative angle minus theta. If I want to measure their cosine, what do I do? We said to measure cosine, you come straight down, or here straight up. What is cosine? Cosine is this stretch. Or let me color it. I'm running out of colors now. This is not sure I helped anything. So that is cosine. It is also, you see, cosine of the negative theta. So that identity gets to be proven by looking at the geometry of the unit circle and the two angles. They turn out to be same. How about tangent? We can do it by unit circle, or we can talk it out like this: tangent of minus theta. But tangent is a ratio of sine to cosine from the definition. Sine of negative theta. Sine, we can simplify it as minus sine of theta. Cosine of negative theta, we just mentioned, that is same as cosine of theta. So this is minus sine over cosine. Now sine over cosine is just tangent. So in this type of reasoning, you see I start from one side, I go through some intermediate identities I know about until I arrive at the other side, which is what presumably I wanted to show. So these are the negative angle identities. So we have covered pretty much the most basic of these identities. Let me mention the other identity I just used. Sometimes they are classified under reciprocal identities, but so I don't know if there is a title for these things. For well, I don't see any name given to it, but what I just used, tangent of any angle is a ratio of sine over cosine. What do you think cotangent of an angle is? So let's call it other basic identities. Of course, you remember you can always rearrange this in other format. Okay, that's the end of easy identities. And after that, things are going to get more and more complicated. Before we go there, let's do a few exercises. So section 2.1, we are going to split it into two pieces. Here, one example. It says simplify. This is sine of phi minus cosine of phi squared. Now, this is one of those mysterious commands in mathematics. Simplify. What do you mean, simplify? It's a really open-ended question. Let's see if you can understand it by doing some exercises. Idea, of course, is we're going to carry this thing out, and after we do our first round of algebra, perhaps things can be done to that to simplify it or shorten it. First is the algebra itself. If I have an expression, I want to square it, what's going to be on the right-hand side? I have sum or difference of two terms, I want to square it. Let me just remind you, some algebra identity we had, we need to know that before we go any further. What's the square of a minus b? Let's get you started. A squared, what else? Is it plus b squared or minus b squared? or you wanted to say minus what? There are different ways of writing it, but everybody comfortable with this? A minus b squared is a squared plus b squared minus 2ab. You need to know that from college algebra before we get going. Difference of two terms squared, sum of their squared, remember, is the sum. The minus evaporates when you square. Let's see how. A minus b times a minus b. When I multiply a with a, well, there is no arguing over that. When I multiply minus b with minus b, the two negatives cancel each other out, and I get my b squared. Where does this guy come from? That comes from a times minus b. That's one piece of it. And the second piece of it is minus b times a. So it becomes minus 2ab. In short, when I square this, what am I going to get? Sine, so square of the first, square of the second, minus twice the product. Now this is like seeing an opening, seeing a move that you can make, like on a chessboard or checker or something. This is something I can do. And you got to do it. And the question is open-ended. It doesn't tell you what to do next. It says, show me that you know what you can do. So sine squared plus cosine squared, we know from our Pythagorean identity. What is that? 1. Is that right? Sine squared plus cosine squared is 1. 1 squared or 1. Now everybody agrees that this is simpler than that. Everybody doesn't agree that this is necessarily simpler than that. Anyway, you get it going, and then you try to show the best you can do with respect to simplification. Yes. Okay, notice how different these questions are compared to algebra. In algebra, almost 99% of cases you come across, you have some very specific procedure to follow. In trigonometry, you are going one level higher up. You are kind of on uncharted seas. You are somewhere you don't necessarily have a very clear procedure to follow. Okay? That only comes with a lot of practice. Let's see, like problem 10. It says tangent square of theta well, let me change this thing to 11 because this is not going to show me anything. Sine to the power of 4 of x minus cosine to the power of 4 of x. Heading says factor and simplify. Before we get into this, let me say that we are going to give one answer now and another answer by the end of the week. So there are different levels we can do depending on what we have studied up to that level. Okay, let me take you back to college algebra. Suppose we had something similar to that. A to power of 4 minus b to power of 4. Same question could have shown up there. A bit simpler though. Over there the question is simply factor. Here is factor and simplify. So we are not going to get to the bottom of this thing today. For sure, exercises of 2.1 are going to be extended at least one day. However, you can go and do some of the basic ones. Okay, let's go back here. A to the power of 4 minus b to the power of 4. What would you do on this thing in college algebra? It's a difference of squares. Like you can think about it, 1 squared minus another square. Now for a moment, ignore that stuff in the parentheses are kind of complicated things. If you had difference of 2 squares like x squared minus y squared, what would you have done there? X minus y times x plus y, is that right? So here you say the same thing. I have 2 things squared, except the items that are being squared themselves are having some shapes and such. But I do the same thing. I say difference of those 2 items times the sum of the same 2 items. The story somehow doesn't finish here though. In college algebra, they might have insisted that you can still break this up. A minus b times a plus b. And this guy is still here. That one we cannot factor it. Not without the aid of some complex numbers and such. Now, let's this problem. We had, let's go back here. We had sine to the power of 4 of x minus cosine to the power of 4 of x. So remember, this is really sine squared being squared minus cosine squared being squared. Which, according to what we did here, we can write it as a difference of these 2 times the sum of the same 2 things. But in trigonometry, before I go to the next stage, I pay attention to something, which is what? What observation can I make on that? That is just 1. Is that right? Sine squared plus cosine squared. That is this. Okay? So, by now, what is left of this is sine square of x minus cosine square of x. As I mentioned, at the end of this week, we are going to have another identity for this, so-called double angle identity. But right now, all we are going to do to it, you say, okay, if you want, you can factor this. If that makes you happier, you can factor this one more round. Sine x minus cosine x times sine x plus cosine x. Okay, so get started on problems of 2-1, and we will talk about anything of the following type. Put it aside. Anything that looks like sine of a plus b, those are called sum and difference formulas. We are going to talk about these things tomorrow. So we are going to talk about these things tomorrow.